Welcome back to College Algebra. This is section 3.5, and just to give you a couple of reminders about what's coming up due. So homework number, this material is going to be on homework and quiz number 9. Like I said, this is section 3.5. Homework and quiz number 9 are 3.4, 3.5, and 3.6. And this is all opened on March the 23rd and is due on Friday, April the 3rd at 11:59 p.m. So you'll be able to do that. Reminder that on this quiz, this is the first quiz where you only get one attempt at the quiz, and it will be a combination of multiple choice and fill in the blank questions. So you have to have a 75% on your homework in order to access the quiz, and really encourage you to get that 100% on the homework and have watched this video and the one more that follows this one before you take that quiz. So hopefully you'll get a good grade by doing that. So, all right, so let's get started. Like I said, this is section 3.5. We'll be talking about the algebra of functions and composite functions. So basically we're going to be putting functions together. So these are our first four. We're not going to spend a lot of time talking about the domains, but we'll spend a little bit of time talking about those. So we have two functions. We'll call them f and g. They can be anything. The operations on these functions are addition, subtraction, multiplication, and division. And so they are the sum, the difference, the product, and the quotient. And we'll be literally just taking functions and adding them, subtracting them, multiplying them together, and then dividing them. The division ones are where we're going to see the biggest change in the domain, but we'll talk about those as we get to them. So let's start with this first problem. Number 1, we have two functions. F of x is equal to x squared plus 2, and g of x is equal to x minus 1. We're going to do four different things. We'll start with adding the two functions together, then we'll subtract the two functions, we'll multiply the two functions, and then we will divide the two functions. Let me just state to begin with that the domain of both of these functions we can write like this. The domain of f is negative infinity to positive infinity, because it's a polynomial function, and the domain of g is exactly the same thing, because once again it is a polynomial function, so it's negative infinity to positive infinity. So let's start with part A for this one. We want to find f plus g. This is the same thing as taking our function f of x and adding it to our function g of x. Sometimes I like to write it out like this. The function f of x is given by x squared plus 2, and then the function g of x is given by x minus 1. So here's my f of x and my g of x. When I combine these together, I just see one set of like terms, so my x squared, there's no other like term, and then plus x, and then I have 2 minus 1, which is going to give me plus 1. And so this is my new function f plus g. Okay? So we'll move on to the second part of this, and that is to find f minus g of x. So we'll take our function f of x, and we will subtract from that the function g of x. Order is very important when we're talking about subtracting. So I am going to put these in parentheses because we are subtracting, so we just need to be a little bit more careful. X plus 2, and then minus x minus 1. When we subtract these, we'll drop the parentheses because we'll be changing some operations in here. So when we write this again, we can drop the parentheses here. We drop the parentheses in the second part. We're going to make this minus x and then plus 1. That's what happens when we distribute that negative sign. So this is then going to become x squared minus x, and then 2 plus 1 is going to be plus 3. And this is our new function f minus g of x. For part 3 of this, or part C, it says to find f times g. So this is where we're going to take the function f, and then we're going to multiply that times the function g. We definitely want to put these in parentheses, otherwise we'll forget to distribute things. So x squared plus 2 multiplied by x minus 1. We are going to FOIL this out I'm going to move the page down just a little bit so we can see what's going on here. So when I multiply this together, I'm going to get x cubed minus x squared. Remember, we're foiling this, x squared, and then plus 2x, and then minus 2. And that is our new function, f times g. Now for all three of these, the domain for all of these is going to be the same. All of these final functions are polynomial functions, and so the domain for all of these will be negative to positive infinity. Notice that I stopped before I got to part D, and part D is the quotient, and so it says f divided by g. This is really easy to find, but a little bit harder to come up with the domain. So we're going to take our function f, which is our x squared plus 2, divided by our function g, which is x minus 1. That is our new function. We are done. Now, the domain we have to be a little bit more careful with because we have a variable in the denominator. So if you remember when we talked about rational functions, so for the domain of this function, we have to find what makes the denominator 0. So we set x minus 1 equal to 0, and we find that x is equal to 1 is a problem. And so we have to remove this value. So we've talked about that when we talked about the domain of rational functions. So we say that the domain of this function is negative infinity to 1, and then we use a union symbol to say that we're jumping the number 1, and we go from 1 to infinity, and so this is the domain of that quotient of functions. For the second problem, we're going to do the same 4 parts, but before we get started, we're going to talk about the domain. This first function f has got a little bit of a different domain. The second one is just negative infinity to positive infinity, but we have to use what we call the most restrictive domain. So for this function, the domain, remember what's underneath the radical has to be greater than or equal to 0, so we can simply say 0 to positive infinity. The domain for this function is going to be all real numbers, but for anything we combine using these functions, we have to use this one because it's the most restrictive. So let's start off with part A, where we're going to add f plus g. So I'm not going to actually write out the f of x plus g of x for these like I did on the first ones, but we'll just rewrite this as the square root of x. That's my f function. Plus x plus 6, that's my g function. There are no like terms, and so we're done. That's all we can do for this function. Okay. So for the second part of this, for the f minus g, once again, we're going to have the square root of x is my f function, minus, I am going to put this in parentheses so that we don't forget to distribute that. So this is going to be the square root of x minus 6, and then that is my new function. So yay, we're happy with that one. Okay, so then the third part of this, f times g, I'm going to put the second one in parentheses just because I don't have but one term for that first part. So this times x plus 6, square root of x times x plus 6, this is a perfectly fine way to leave your answer. To distribute that square root is really not going to help anything, so I would leave it just like this. Now, just like a while ago, all 3 of these have the same domain, and we are going to use the most restrictive one up there, the square bracket 0 to positive infinity, and that's going to be to the domain of these 3 pieces of this. So for the fourth piece, the quotient, we are going to have to pay attention to this one, so f divided by g. Once again, my function f is the square root of x. My function g is x plus 6. Let's talk about, so this is my new function, but what would make this denominator 0? So let's plug in, let's take x plus 6 and set it equal to 0. Not really plugging in. So this is going to give me x is equal to negative 6. Is negative 6 in this restricted domain? The answer is no, because negative 6 is outside of this. This is only for positive numbers. So this domain is actually the same because we've already restricted that pretty well. So the domain for all 4 of these new functions is the same thing. It's that 0 to positive infinity. I don't have to worry about this negative 6. Okay. So now we're going to take this a step further and we're going to talk about adding functions together and evaluating that new function. So there are a couple of ways we can do this, and I think the easiest thing is to tell you to find f of 6 and then find g of 6 and then add those together, and that's the way we're going to do this. So here's my function f, this is my function g, and here's my function h. So we have three different functions. For this first part, we're going to find f of 6. So it's almost like a distributing property. It's really not, but it kind of looks like that. And then we're going to find g of 6. So to find f of 6, we're going to come up here to my function f. And so I'm going to, we can just go ahead and plug it in here. So this is going to be the square root of 6 minus 2. That's going to be my function f. Let's change colors to do the g. Plus g of x, we're going to use the x, or put 6 in there, plus 5. So for the first part, for the f function, this is going to be the square root of 4, which is going to give me a value of 2. And so to find g of 6, we've evaluated functions earlier in the semester. So 6 plus 5 is 11. And so now I have 2 plus 11. And so this value, kind of draw a little line up here, is going to be 13. And that would be my answer to this function. Okay. All right. So let's do f minus g of 11. So we're going to go do exactly the same thing. So this is going to be f of 11. And then we're going to subtract from that g of 11. So we're going to actually go through and we're going to plug these in. So f of 11, this is going to be the square root of 11 minus 2. Let's go ahead and finish that part out. So that's the square root of 9. And the square root of 9 is 3, kind of squishing this in here at the bottom. And then we'll do g of 11. So g of 11 is what's going to happen when, now I'm going to put this in parentheses, minus 11 plus 5. We're plugging that 11 in for x. So 11 plus 5 is 16. And so I have the square root of 9 minus 16. And so now I'm going to have 3 minus 16. And this is going to give me a value of negative 13. Just happens to be the opposite number up there. No connections. All right, let's come over here and do g plus h of negative 2. So now we're going to use our function h. I know it's a fraction, but it's going to be fine. So this is going to be g of negative 2. And then we're going to add to that h of negative 2. And it didn't change colors on me, so we'll change that in just a second. So this is going to be what happens when I put negative 2 in here. So I have negative 2 plus 5 is my g value. Negative 2 plus 5 is 3. And so now changed colors there for me. Plus h of 2, I'm going to plug negative 2 in here for x. So I'm going to have 1 over 2 times negative 2 plus 3. This is going to possibly give me a fraction, but it's okay. So we're going to simplify this just a little bit. So I have 1 over negative 4 plus 3. So I'm going to kind of keep these separate for you. So this is 3. This is my g of negative 2. And then plus. And so this is going to be negative 4 plus 3 is actually going to be negative 1. So that's not going to be quite as bad as we originally thought it might be. And this is going to be 3, and then 1 divided by negative 1 is minus 1, and so 3 minus 1 is going to give me a value of 2. And so g plus h of negative 2 is just going to be a positive 2. Right? We have one more of these to do, and this is going to be f of 3 divided by g of 3. So we'll be plugging 3 into both of those functions again. So f of 3, going back to our f function, is going to be the square root of 3 minus 2. And g of 3 is going to be, we're going to go back to this function, 3 plus 5. In that denominator, we're going to end up with an 8. 3 plus 5 is 8. The square root of 1, we're very happy to know that the square root of 1 is 1. So I have 1/8, and so I can say that f divided by g of 3 has a value of 1 over 8, and that would be my final answer here. Okay? So now we're just going to evaluate those at each piece and then either add or subtract. Okay. Moving on to the next part, we are looking at the graph here. So in case your screen happens to be black and white, you can see that g of x is going to be our red graph, and that's this graph right here, and f of x is our green graph here. So we're actually going to be evaluating these using the graph. So I'm going to try to use the red and the green to combine these. So with my green function being f, so this is going to be, what I need to do is I need to find f of 1, and then I'm going to find g of 1, and I'm going to be using the graphs to do this. So back a while we talked about how to do this. So we're looking for the y value when x is 1 on the green graph or the f of x graph. So I'm going to come over here to 1. I'm going to go up to my graph, and I see that there is a point here on my graph, and that point has the ordered pair 1, 1. And so that tells me that f of 1 has a value of 1. I'm going to add to that the value I find for g of 1. So again, I'm going to 1 on the x-axis. I'm going to my red graph or my g graph. There's a point here, and this is the ordered pair 1, negative 3. So g of 1 has a value of negative 3. And so now when I combine these two values together, I find that 1 plus negative 3 has a value of negative 2. And so that means that f plus g of 1 is negative 2. We're going to do exactly the same thing with the next one, except we're going to be subtracting these values. So I want to be able to find f of 2, and then I want to be able to find g of 2, and then I will subtract those two numbers that I get. So my y value for f of 2, I'm going to go to 2 on my x-axis. I'm going to my ordered pair that's on that green line, and so that actually has the value, the ordered pair 2, 2. And so f of 2 has a value of 2. And then I'm going to stay with that x value of 2, and I'm going to go to the red graph or my g function. There's an ordered pair there of 2, negative 4. And so the y value for g of 2 is negative 4. Notice I'm subtracting, so I'm subtracting that negative. And so when I combine these together, this is going to be 2 plus 4, which is going to give me a value of 6. So for the next part, we're going to be multiplying these using those same graphs. So exactly like I did before, except once I get my numbers, I'll be multiplying. So f of negative 1, and then I want to multiply that by g of negative 1. So when I do this, f of negative 1, I'm going to go to negative 1 on my x-axis, come down here to this point, and so this is the point negative 1, negative 1. So f of negative 1 has a y value of negative 1. G of negative 1, back to that same x value, up here to my graph that's g, that ordered pair is negative 1, positive 5. And so the y value for g of negative 1 is positive 5. I multiply these two numbers together. Positive and negative gives me a negative, and so my final answer for f times g of negative 1 is negative 5. And then finally, we're going to do exactly the same thing, except now we're going to be dividing with these values. So f of 4 is going to be divided by, g of 4. So I'm going to go back to my graph. You may have kind of figured out this f graph. It's kind of boring. We keep getting the same y values. So x is equal to 4. Here is the point on the graph of my function f. It is the ordered pair 4, 4. So that y value is 4. So now let's find the g of 4. So here is 4 on my x-axis. Here is my point. That ordered pair is 4, 0. So g of 4 actually has a value of 0. Now we have a small problem, and you might be realizing that the directions said or state that it is undefined. Remember, division by 0 is undefined, so since I have 4 divided by 0, we say that this we cannot find, or we call it simply undefined. Right? Moving on to the next function. the next slide, excuse me. So on this one, we're going to be talking about a new operation, and this new operation is called the composition operation. It's defined by this little circle, and it's actually defined by taking the second function and plugging it into the first function. So if you see this little circle symbol, this is the same thing as rewriting the second function as what we call our inside function, and it goes into the first function or our outside function. So let's talk about this composition. So we'll start here. It says to find g of f of x. I really like to write this using this notation. So I would say g of, and then we'll plug in this f of x. So g of f of x. And so you'll see me do this on every one of these problems. So the next step, I'm going to actually replace that notation of f of x with the function f of x, which is defined as 3x plus 1. So now what I want to do is to find g of 3x plus 1. We did some problems similar to this in one of the first sections in this chapter, where we found things like g of x plus 2 or maybe f of x plus h. So same kind of concept here. So now I'm going to go to my g function. The g function is defined as 2 over x plus 1. And so in place of that x, I'm going to put that function f in there. So I'm going to kind of leave this little holding ground for my x. And I'm going to, instead of x, I'm going to put in 3x plus 1. If you want to put a parentheses there, that's fine. You don't have to, but it's kind of nice sometimes. So I can clean this up, and this is still 2 in the numerator, and then I have 3x plus 2 in the denominator, and so that's going to be my new function, which is the composition of g of f of x. Okay. So we're going to do the same thing except using two different functions here. So once again, my first function is my outside function, so this is going to be f of, and then my second function is my inside function, so f of h of x. So for this particular problem, I'm going to be using the two functions up here, f and h, and so I'm still going to use this notation f of, and in place of the notation h of x, I'm going to replace it with that actual function, which is the square root of x plus 3. I'm going to slide the page down just a little bit so we can put this in here. And so if you recall, my f function is 3x plus 1, and so now I'm going to have 3 times, and in place of that x, I'm going to put a parentheses, and then I'm going to drop that h function right in here. Now you can lose the parentheses as you rewrite this if you want to, and you can write this as 3 and then the square root of x plus 3 and then plus 1. You can't combine anything else. There's nothing else you can combine. This plus 1 is outside and this plus 3 is inside, so I'm done. For h of f of x, now notice that this one was f of h and this one is h of f. I'm going to get a completely different function. So my outside function now is my first function still, but it is the function h. And so my inside function is my second function or my f function. So in place of my f of x, I'm going to plug in the 3x plus 1, and so now I'm going to be finding h of 3x plus 1. My h of x function is that square root of something plus 3, and that something is going to be replaced with 3x plus 1. Notice all of this is underneath the radical, and so I can combine like terms, and so this is going to give me the square root of 3x plus 4. This is a completely different function than what I got for number 10, right? The last one of these, I'm going to combine f with itself, so f of x. Same thing I did before. My outside function is going to be my first function, so I need to call this f of x. My inside function just also happens to be f of x, but I'm going to go through this same process. So my f of x is going to be replaced in my inside function with the 3x plus 1. Remembering that my f of x function is 3x plus 1, so I'll have 3 times something plus 1, and in place of that x now I'm going to drop my 3x plus 1. And so now I'm going to clean this up, and I'm going to get 9x plus 3 plus 1, and when I clean this up by collecting together like terms, I have 9x plus 4, and that is my final answer. So now we've put two functions together using the operation composition. On this one, similar to what we did earlier, we're going to evaluate the composition of functions. There are a couple of ways we could do this, but I'm going to do this what I think is the most straightforward way. So if you happen to know another way, that's all right, but I'm going to do this by finding inside and outside again. So g of x is my first function, so it's my outside function, and f of x, and in this case I'm going to be evaluating f of 0, is my inside function. So I'm going to rewrite it like this. The first thing I'm going to do on these problems is I'm going to evaluate this inside function, so I need to find an actual value here. So I'm going to be plugging 0 in for x, so this is going to be 3 times 0 plus 1. 3 times 0 is 0, and so I find f of 0 has a value of 1. In a minute we're going to be looking at graphs, and so I'm going to be looking for the y value of that point on the graph. So now I just have this y value, and so I will be plugging that into my g function or my outside function. So instead of finding f of 0, now I need to find g of 1. So now I go to my g function, and my g function is 2 over x plus 1, but my x value is going to be replaced by 1, so I have 2 over 2, which is going to give me a value of 1, and that's going to be my final answer. I'm going to do the same thing here with this next one. So again, my outside function is my f function. My inside function is the second function, which is h, so I will be evaluating h of 6 to begin with. So I like to come over here to the side and find h of 6. So I'm going to find the square root of 6 plus 3, which is the square root of 9. So I find that h of 6 has a value of 3 because the square root of 9 is 3. So now I'm going to plug that into my f function. So rather than finding h of 6, f of h of 6, I'm going to find f of 3. So I go back to my f function. It's kind of a lot of going back and forth. 3 times something plus 1, that something is going to be 3. And so I have 3 times 3 is 9, and 9 plus 1 is 10, and so that will be my final answer here. Flip-flopping this around, h of f of 0, h is still my outside function because it is my first function, so the first function is always your outside function. So h of f of 0, so I actually found f of 0 over here in the previous problem, so I know that f of 0 has a value of 1, so I can plug 1 into my h function. So rather than having f of 0 here, I will be finding h of 1. My h function is this square root, and so I have the square root of x plus 1, x plus 3, excuse me, but that x is a 1. So I have the square root of 4. The square root of 4 is a very nice 2. And then finally we can find the composition of f of negative 1. Exactly what we did a while ago, except we have a value to plug in. So I'm going to be finding f of negative 1. So I will move over here to the side and ask you to find f of negative 1. So I have 3 times negative 1 plus 1. This will be negative 3 plus 1. So I find that f of negative 1 has a value of negative 2. So now when I can plug this in, I will be finding f of negative 2. So my f function is still that 3 times x plus 1. My x value is negative 2. This is going to give me negative 6 plus 1. Negative 6 plus 1 is going to have a value of negative 5, and that's my final answer there. We have one more problem to do in this section, and it does have to do with graphs. We're going to be doing exactly the same thing we did on the previous page, except that we'll be using the graph to help us find those y values. So again, here my g function is in blue, and my f function is in red, and so I'll try to correspond those to these different colors here. So my outside function, here is my f function, so it's going to be my first function. So this is the same thing as asking you to find f of, and now my g function is that inside function, so g of 1. So I'm going to find g of 1 using the graph. Going to go to 1 on the x-axis, go to my function g. I find that ordered pair to be 1, 2, and so g of 1 has a value of 2, and that's all you need to do there. So now what I want to do is I want to find f of 2. So now I'm going to go to 2 on the x-axis. I'm going to go to the function f down here. So I'm going to slide this down a little bit, so hopefully we can get this in here. And f of 2 is going to be almost off the screen down here. Sorry about that. This is going to be the ordered pair to negative 4. You may have to trust me on that. So f of 2 has a value of negative 4, and so that's going to be my final answer here. Going to do this one, start with my first function, which again is going to be my outside function, so I need to find g of f of negative 2. So I go to negative 2 now on my x-axis. I'm going to go to my f function. You're going to have to trust me just a little bit on this one. This is the point negative 2, negative 4. So as I look to find f of negative 2, this is going to have a value of negative 4. So now I can find g of negative 4. So my y value essentially becomes my x value. So again, I'm going to go to the x-axis. I'm going to find negative 4. I'm going to go to my blue function, my g function, and I'm going to find that ordered pair where x is negative 4, and in this case y is negative 3. So g of negative 4 has a final value of negative 3. So this composition here is going to have a final y value. So the third part of this says we're going to do g of 0. Still, my outside function is that first function, so I need to find g of, and in this case, g of 0. So I go to 0 on the x-axis. I go to the ordered pair on my g function. That ordered pair is going to be 1, 0, 1. And so g of 0 is going to have a value of 1. So this means I need to now find g of 1. So I go back to my x-axis. I find that point. We've actually already used this. We find that g of 1 has a y value of 2. Now finally, this is a three-part composition. We work inside out just like order of operations. So I'm going to do this as g of, and we'll kind of do this as an embedded function, f of, and then we'll go back to g of, and it's going to be 1. So we start by finding g of 1, which we already know has a value of 2. So this is going to become g of f. Oops, sorry about that. I am going to erase that so that we can kind of stay color coordinated here. So f of, and then my y value 2 goes in here. So going to the second part of this is I need to find f of 2. F of 2 we actually found already is negative 4. So now, negative 4. So now I'm going to go back one more step and I'm going to find g of negative 4. and g of negative 4. We've actually already found that one also. Makes it a little bit nice. G of negative 4 has a value of negative 3. So once again, I'm going to that x-axis. My inside number is always coming off my x-axis, and my value is always coming off the y-axis. And that's it. So make sure you do the homework, use the help features on the homework, and if you're interested in tuning in for office hours, I am going to plan to host those on WebEx during class time on both Monday and Wednesday, and we'll find out on Monday at 9 o'clock how well that works. And if it doesn't, we will go back to the drawing board and figure out a new method. So hope you have a great day, and bye.